So in this video, we will be continuing with some trig stuff, doing tangent lines and horizontal tangents. In order to find the normal or perpendicular to the tangent line, as you know, you need an x, a y, and a slope value. Starting with slope, we take derivative of the given equation y equals sine x and find that dy over dx equals cosine x. Since we are given the x value, we plug in pi over 6 into the derivative and get radical 3 over 2, since that's cosine of pi over 6. Then we plug pi over 6 into the original equation and get 1/2, since that's sine of pi over 6. The equation of the normal is found using the x value, the y value, and the negative reciprocal of the slope value. So the normal line would be y minus 1/2 equals negative 2 over radical 3 x minus pi over 6. And fully distributed, it would be y equals negative 2 over radical 3x plus 2 pi over 6 radical 3 plus 1/2. Fully simplified, the normal line is y equals negative 2 over radical 3x plus pi over 3 radical 3 plus 1/2. The next example is determining where the function y equals x plus sine x has any horizontal tangents. Again, we start by taking the derivative, so dy over dx equals 1 plus cosine x. Since it's horizontal tangents, we set our derivative equal to 0, then we solve for x by subtracting 1, and finding the x value at which cosine equals negative 1. So in this case, x equals pi. Once we plug pi into the original equation, we get y equals pi plus sine pi, or pi plus 0, which just equals pi. So the point slope form ends up being y minus pi equals 0, x minus pi. Once the 0 is distributed, you can move pi over to simply get y equals pi. The last example is similar to the one we just did, finding a horizontal tangent, but the function is now y equals 1/2 x plus cosine x. Take the derivative of the function, so dy over dx equals 1/2 minus sine x. Set the derivative equal to 0, and solve for x by rearranging. So x will equal pi over 6 and 5 pi over 6, since sine is positive in quadrants 1 and 2. Then plugging pi over 6 into the original function, we get 1/2 pi over 6 plus cosine pi over 6. Or simplified, y equals pi over 12 plus radical 3 over 2. Then doing the same with 5 pi over 6, we get 1/2 5 pi over 6 plus cosine 5 pi over 6. Or simplified, y equals 5 pi over 12 minus radical 3 over 2. Since cosine is negative in the second quadrant. With the x value, y value, and slope of 0, we can determine the equations for the two horizontal tangents. The first, using x equals pi over 6, y equals pi over 12 plus radical 3 over 2, and m equals 0, would be y minus quantity pi over 12 plus radical 3 over 2 equals 0, x minus pi over 6. Or simplified, y equals pi over 12 plus radical 3 over 2. Now the second horizontal tangent, using x equals 5 pi over 6, y equals 5 pi over 12 minus radical 3 over 2, and m equals 0, we would find that the horizontal tangent would be y minus quantity 5 pi over 12 minus radical 3 over 2 equals 0, x minus 5 pi over 6. And simplified, y equals 5 pi over 12 minus radical 3 over 2. See me after class.